Today we're going to do Chapter 6, Section 3, Trig Functions of Any Angle. So the unit circle that you're going to see here in this picture, I'm going to zoom in and kind of focus on that. The unit circle is incredibly helpful to us to find basically the trig functions of, again, your special right triangle measurements. Okay, so this is going to be related to those special right triangle amounts. And basically what we're talking about is 30 degrees, 60 degrees, and 45 degree angles. Okay, that's what we're going to focus on. Obviously in quadrant 1, those are the angles we're talking about, right? The 30, 60, and 90 degrees. Not 90, sorry, 45. Okay. And actually, let me do it in increasing order. Let's think of 30, 45, and 60 degrees. In terms of radians, it's the same thing. It's pi over 6, pi over 4, and pi over 3. That's the conversion from degrees to radians. In quadrant 2, we're talking about utilizing those same angles as reference angles. So in other words, if 30 degrees, let's just focus on that one for now. A 30-degree angle would be our reference. In quadrant 2, it would be 180 minus 30 degrees, which would equal a 150-degree angle. Or in terms of radians, it would be pi minus pi over 6, which would be 5 pi over 6. And so again, 30 degrees comes back here. So let's understand what we're even talking about when we talk about these reference angles. Or not reference angles, when we talk about the unit circle. We utilized the unit circle before, and what we did is we created this circle. Okay, so we have this general circle here, and the center of the circle is at 0, 0, and the radius of the circle, the radius is 1. Okay, so every point from the center to the circle, that distance is r equals 1. And we used this before, because we used this when we were trying to find the sine, the cosine, tangent, and all this trig functions, trig values of these quadrantal angles. In other words, when we were at 0 or 360 degrees, we used x is 1, y is 0, and r is always 1. And we found our trig functions based on that. When we went up here to 90 degrees, we did the same thing. X is 0, y is 1, and r is 1. When we did 180 degrees, we did the same thing. We did negative 1, 0, and r is 1. So we had our x, our y, and our r, and we were able to find all of our trig functions. And we went down to 270, and we did the same thing. And so we utilized this unit circle before, but only for these quadrantal angles. We didn't do anything with them relating to 30, 60, 90 triangles or 45, 45, 90. Today, we're going to learn to use this unit circle for those other angles. So you still want to know how to use it for the quadrantals, obviously, but we're going to focus on the other ones. So let's start by focusing on maybe our 30-degree angle. So we're going to create this line or this angle in standard position, and then the 30-degree angle. So this would be 30 degrees, right? And if I take this point on the circle and I go down to the x-axis, I'm going to create this right triangle. Now, normally, you know that a right triangle, the side opposite the 30 is, let's say, A. The side opposite the 60 is A radical 3. This would be 60 degrees. And the hypotenuse would be 2A. So, again, you have a 30, a 60, and a 90 triangle, A radical 3 or 2A. And in this case, we know it's a unit circle, so our radius or our hypotenuse is equal to 1. So if 2A equals 1, we know that A is a half. So the side opposite the 30 is a half, and the side opposite the 60 is a half times radical 3, or radical 3 over 2. So we come back to our drawing. The side opposite the 30 now becomes the half. The side opposite the 60 is radical 3 over 2, and the hypotenuse is 1. And so notice then that this ordered pair up here is located at x is radical 3 over 2 here, and the y is half unit up, so half. And so we get this ordered pair that relates to the x and y value of a unit circle of a 30-degree angle. And so that's really important because that x and y value is going to carry forward in every quadrant, okay, with a reference angle of 30 degrees. So, for example, if I go here to quadrant 2 and I have a 30-degree reference angle right here. Let's say this is 30 degrees. Well, if I was to create this triangle, I would have those same values. My x would still be radical 3 over 2. My y would still be half up. The difference, and the only difference is, so I'm using the same exact ordered pair here. The only difference is that when I'm in quadrant 2, I know my x is negative. Okay, and so instead of radical 3 over 2 and 1 over 2, it's going to be negative radical 3 over 2 and positive 1 over 2. And if I take that same reference angle into quadrant 3, and I go here, and again, this is still 30 degrees, and I create this line down, I turn it into this right triangle, again, I'm going to still get, at this level, I'm going to get radical 3 over 2 and 1/2. Just like in the first quadrant, again, because I'm in quadrant 3, my x and my y are both negative. And lastly, if I go into the fourth quadrant with this reference angle of 30 degrees, okay, I know that I'm going to get this right triangle drawn here from the circle down, and that xy combination is going to be the same, radical 3 over 2 and a half. But because in quadrant 4 only the y is negative, I'm going to make the y value negative. So these four values, notice they are exactly the same. The only difference is that the x's or y's are positive or negative depending on your quadrant. And so when I'm filling out this unit circle, I know that everything related to 30 degrees or its radian counterpart, which is pi over 6, is going to be related to that radical 3 over 2 and half xy combo, okay? R is always 1, all right? When I'm going around my unit circle trying to figure out, let me kind of like erase all this now, right? Let me focus on something else here. When I'm going around my unit circle and I'm trying to focus on finding all my angles that relate to, let's say, that 30-degree angle, I can think of it in a certain way. I know that, you know, in a circle that's worth 360 degrees, if I divide 360 by 30, I'm going to get 12. I know there are 12 angles if I kind of think of 30-degree sections, right? So the first one in terms of, you know, in terms of degree, this is a simple thing. I know it's 30, then 60, then 90, then 120, 150, 180, 210, 240, 270, 300, 330, and 360, okay? I know these are the 12, okay? Now, in radians, it's a little bit more difficult, okay? In radians, when I try to do this, I have to try to think of my radians. I know that pi over 6 is 30 degrees. I know that pi here would be 6 pi over 6, right? So let's think. If I have pi over 6, then it would be 2 pi over 6, which is pi over 3. Then it would be 3 pi over 6, that's my half pi. Then it's 4 pi over 6, simplified, right? And then 5 pi over 6 is here, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi, whoops, not that one. 10 pi over 6, 11 pi over 6, and 12 pi over 6 would be one cycle. So again, if I learn to kind of think about my 30-degree angles in terms of pi over 6, I know that each one is, 1 times pi over 6, this is my second one, so 2 times pi over 6, 3 times pi over 6, 4 times pi over 6, 5 times, 6 times, 7 times, and there's going to be 12 of those. And so, again, just understanding the unit circle, understanding how pi over 6 represents 30 degrees, and knowing how to kind of add the 12 of them in there and know what quadrants and stuff they're in is super important, okay? Then we go to the next number. Let's try 60 degrees. So let's focus on our 60-degree angle now and see how that works within this unit circle. So again, this is 60 degrees, and if I take this point on the circle and I draw the line down, I know that the side opposite the 60, we already know, is A radical 3. The side opposite the 30 is A, and the radius is always 2A. And so again, I know my formula, and I know that my radius is going to be 1. So again, if my radius is 1, I know the side opposite 60 is radical 3 over 2, and the side opposite the 30 is a half. Okay, so I know that this is a half, this is radical 3 over 2, and I know that this is 1. And so yet again, I know my x here is the half, and my y is the radical 3 over 2. So if you notice, the 30 degree and the 60 degree, the x and y swap places. But again, I now know my x and y values in every quadrant. The only difference is, again, if it's in quadrant 2, the x is negative. If it's in quadrant 3, x and y are negative. See it here? And if it's in quadrant 4, okay, I know that the x is positive and the y is negative, but it is still the same combination of x and y. And so again, you go around the unit circle and you're going to be able to solve and plug in all of these values that you need, okay? And so again, let's look at how we would do that, right? So we come over here, and I know if I was just doing this with 60 degrees, right? I know it would be, I'm here, right? I would do 60. I know this would be 120. I know I have 180, 240. I have 300 and 360. Well, and that makes sense. I know that in 360 degrees, if I divide it by 60, right, I'm going to get 6 angles. And so if I know that 60 degrees in radians is pi over 3, I know this one's going to be pi over 3 radians. This is going to be 2 times pi over 3 radians because it's my second one. The third one is 3 times pi over 3 radians, just pi, right? The fourth one is 4 times pi over 3 radians, or 4 pi over 3. The fifth one is 5 pi over 3 radians, and the last one is 6 pi over 3, which is 2 pi. And again, if you kind of think about it in those terms, it's easy for you to think of the 60 degree or the pi over 3 throughout all of the quadrants, okay? And then the last one we're going to show you is how do we identify the x and y of a 45-45 triangle, right? So I've got 45, 45, 90. You know that that's A, and A radical 2. So the radius in these problems is always 1. So if A radical 2 equals 1, we know that A is 1 over radical 2, right? And so we know our radius is 1. That's not a problem. But our A is 1 over radical 2, which when you rationalize the denominator is radical 2 over 2. So our x and our y, those are our legs, is going to be radical 2 over 2 for both the x and the y of that point. So again, here I come to my 45 degree angle here, right? This is 45. I'm going to create this line down, and I know this is going to be radical 2 over 2. This is radical 2 over 2, and my radius is 1, because on the unit circle, it's always 1. And so there's my ordered pair. So it's the same number both times. And again, each quadrant, it's just going to be in quadrant 2, only the x will change to negative. In quadrant 3, both the x and y will change to negative. And in quadrant 4, only the y will change to negative. But it is, in fact, the same angle each time, the same reference angle. It's going to be 45 here, this one here. Whoops, not that one. This one here is 45, and then this one here is also 45. And so we're constantly looking at those reference angles. And again, remember those reference angles come from, you know, that the reference angles come from the comments that we know the reference angle is the angle, the ending angle in quadrant 1. In quadrant 2, 180 minus the reference angle equals the angle you're looking for, right? Or in terms of pi, it's pi minus the reference angle, or in terms of radians rather, right? In quadrant 3, it's 180 plus the reference angle equals the angle that makes that, and then it's pi plus the reference angle in terms of radians. And the last one is 360 minus the reference angle in terms of degree, or 2 pi minus the reference angle if it's in radians. Okay, so if you want to know what degree measure is going to give you a reference angle of 45 degrees, well, that's 180 minus the reference angle, and you're going to get 135 degrees, okay? Or in terms of radians, you're going to do, in terms of radians for that same problem, you would do pi minus, and if you have 45 degrees, you know that that's going to be pi over 4. Well, pi is the same as 4 pi over 4, and so 3 pi over 4 is the angle that's going to have this reference angle, and that's how you get that. And so again, we managed to, as long as you understand, how reference angles work, and hopefully by now you do, you can find those as well. Okay, so now that you know all your values, okay, if we're going to give you a chart, and we're going to ask you to fill all of these values in. Okay, so again, if you know the first quadrant, you're pretty much solid on the rest, because if you know that 30 degrees is equivalent to pi over 6, and this is the XY combination, then you can do, again, that reference angle over here in quadrant 2. It's 150, it's 5 pi over 6, and it's those same two values. And so you just kind of go through and identify all of these go with that 30 degrees, reference angle. These all go together. Then you have the 45 degree, pi over 4, 2 radical 2, 3 pi over 4, 135, 2, same thing, right? You go into third quadrant, and you go into your fourth quadrant. And then lastly, you come and you go to the third one that we're going to do, which again is the 60 degrees. And you get your values here. And so these are the ones that you're going to want to memorize. And how you choose to memorize them is up to you. There are other videos of other teachers and how they sort of teach it. Again, this is 90 degrees. This is 0 and 360, pi. The blue ones we've known before. These last ones I'm doing, the quadrantal angles we've used. But if you notice, if you can just memorize quadrant 1, then you know how to apply to quadrant 2. You know these all match, and so hopefully you can kind of see that structure to it. Okay. Some teachers teach you different tricks. If you look at Miss Ferrier's videos or Miss Chris Weiser's video, they go into a little bit more detail on how maybe you can use a pattern. For example, you notice that the denominators of all of these, the denominators are always 2. You might see that the number, these are the ones above the x-axis. You're going to see that it's like square root of 1, which is 1, square root of 2, square root of 3. So it's basically square root of 1, 2, 3. The x's go in descending order or ascending order, and then the y values do the opposite. So they do square root of 3, square root of 2, square root of 1, which is 1. So that's kind of interesting. And the same goes here. The x's are ascending order for the numerator and descending order, or not the numerator, for the x's, and descending order for the y's. I don't love that method because when I go below the x-axis, it changes. The x's go in descending and the y's go in ascending. And so I find it confusing. That's not how I learned it. But again, other teachers have different methods, and this is probably a great chapter for you to go through other teachers' videos and see what works for you. Okay. Because our sine and our cosine, our ratios never really change. It's y over r, x over r, y over x, and then the cosecant is r over y, r over x, and x over y, right? This is not that. That's this cotangent. Okay, there's an error there. But because these ratios used to be over r, something changed between when we learned them in the beginning and now. And the reason they changed is because in this unit circle, since the radius is always 1, well, we don't need to put anything over 1 is itself, right? So the sine is just the y value. The cosine is just the x value. And when I do the cosecant, instead of r over y, it's just 1 over y. The secant is 1 over x, okay? And then the tangent and cotangent are x and y's, and so that doesn't affect, the radius doesn't affect those. But if I came here and I asked you for the sine of 45 degrees, you're going to come right here, and it's going to be the y value of that ordered pair, which is radical 2 over 2. That's it, okay? If I ask you for the cosine of, let's say 3 pi over 4, you're going to identify 3 pi over 4 here, and you're going to tell me the x value because the cosine is the x value, so negative square root of 2 over 2. If I ask you for the cosecant of, some value, let's say the cosecant of pi over 3, let's say I ask you in radians, right? Well, the cosecant pi over 3, this is the xy combo, and the cosecant is going to be 1 over the y value, and the y value is radical 3 over 2. So you have to do a little bit of math there. That's the same as, let's say, one way to do it. You can just flip it, but it's 1 divided by radical 3 over 2, which means stay, change, flip. And so I know that the cosecant of this is going to be 2 over radical 3. Unfortunately, I do have to rationalize that, and I get 2 radical 3 over 3. And so that's my final answer for the cosecant. But everything comes from these values here, these x, y, and radius 1 combination. Okay? And so I think that's super important. And however you need to do it quickly and effectively, that's what you need to do and figure it out. Because we're going to give you an assessment. And all of these things that have numbers here that I highlighted, all of that is going to be blank on your assessment. And you have to basically go in there and fill in the spots. Once again, I highly recommend you memorize completely the first quadrant because this is your starting point. Once you know your first quadrant, I think you should be able to carry everything over to all the other quadrants. So now we're going to use the unit circle to answer these questions. And so what you're going to do is you're going to have your unit circle, and you're going to have it labeled. Let me see if I can get a copy of the unit circle into this screen. Okay, so I copied in a unit circle into this slide. And so the first problem that we're going to do is the sine of 3 pi over 2. So again, we have to know where 3 pi over 2 is. One tip is if you turn these improper fractions into mixed numbers and you realize that 3 over 2 is 1.5 pi. And again, before looking at the unit circle, you know this is 0, you know this is pi, you know this is 2 pi, and then we go back and this would be 3 pi and 4 pi and things like that. And so you know that between pi and 2 pi would be 1.5 pi. In fact, 1.5 pi would be right in the middle. So it would be around here. So I know that it's probably at the 270 degree, but let's look at our unit circle. And we see that 3 pi over 2 is exactly there at 270 degrees. And so we see that the x and y coordinate is 0, -1. So again, the coordinate that goes with it is 0, -1. And so the sine, we know, is the y value. So it's -1. The second problem is the cosine of that same point. Well, again, the cosine is the x value, which in this case would be 0. The tangent of 3 pi over 2 is going to be, remember, tangent is y over x, and so the y value is -1, the x value is 0, and so that would be undefined. And so that's the tangent. Now we go to the next point, 7 pi over 4, and again, you want to think about that as 1 3/4 pies, or pi. And so I know that's 1 3/4 pi radians, which again, 2 pi is 1 complete revolution, so this definitely is going to be in quadrant 4. So let me find 7 pi over 4. The denominator also is going to tell me that my reference angle is that 45 degrees. So when I come over here to 7 pi over 4, I notice that it's this 315 degree angle, okay? My x and y combination is here. So radical 2 over 2 for both, right? So let me kind of put my x, y. I know it's radical 2 over 2 for both of them, but because it's in quadrant 4, I know my y is negative, okay? So the cosine is the x value, which means it's radical 2 over 2 is my answer. The sine of that same value is going to be the y value, which is negative radical 2 over 2. And then we go to a new angle here. We've got negative 5 pi over 3. So this is negative 1 2/3 pi. So again, I'm almost at 2 pi, but it's negative. So I know that this is going to probably end up in quadrant 1. That's going to be my best guess. And so I'm going to try to figure that one out. So negative 5 pi over 3. Remember, pi over 3 is 60 degrees. So, I'm going to go pi over 3, then I'm going to go another pi over 3, a third one, a fourth one, and a fifth one, and it's right here. And it's going to take me to here. So that's negative 5 pi over 3 is the same as the tangent of another coterminal, which is pi over 3. That ends in the same place. Pi over 3 and negative 5 pi over 3 end in the same spot. And I know that my x and y combo is going to be a half and radical 3 over 2, both positive. And so now I'm able to answer the question. So this is kind of all the information leading up to it. Tangent of this number would be y over x. And in this case, the y is radical 2 or radical 3 over 2. And the x is a half. Now, when I see this, I prefer to do radical 3 over 2 divided by the denominator. And then I know that that's a stay, a change, and a flip. And I'm going to end up with square root of 3. So I know that my tangent is the square root of 3 for that one. Okay. Last two, I've got the cosine of 2 pi over 3. So this is close to 3 pi over 3, which would be pi. So my guess is this would be in quadrant 2. So let's look for 2 pi over 3 in quadrant 2, and there it is. Here's my xy combination, and it asks me for cosine, which means it wants the x value of that, which is negative 1 over 2. I feel like I just moved this. Okay, so it equals negative 1 over 2. And that's my answer. It's the x value of this ordered pair. Oh, wait, it's not that one. Sorry. It's over here, and it's negative 1 over 2. That's the answer. And then 4 pi over 3 is 1 1/3 pi. And so I think this is going to end up being, my guess is it's in quadrant 3. Let's see, 4 pi over 3, notice there it is. And again, the xy combination that goes with that value is negative a half and negative radical 3 over 2. The cosine is the x value of that coordinate, so it's negative a half. And that's the answer. Those are the answers to all of these questions. Let me move this out of the way just to kind of see if, I don't think I can move it. Can't move it. Okay. Well, anyway, I think that's all the problems on this page. I'm not 100% sure if there's anything else. Oops, I can actually erase it out. Let's do it. There it goes. Yep, there's nothing else on this page. So that's that.